Okay, what's up guys? I hope you guys are okay. I'm really sorry about the way that I'm recording at the moment. What is that? Okay. It's just some hot glue from the light which I put up there. Anyways, I have moved most of my equipment to my shop. So I'm starting to set up a new work desk at home. Yeah, so most of my equipment is at the shop, my power supply, my new auto station. Yeah, I'm using my old stuff, my old power supply, my old auto station. This is new though. This is just a soldering iron. I can change the tip on it. Anyways, that's besides the point. So from here, I had this Acer laptop. Yes, it's an Aspire E something. Well, it says Aspire E1 510. That's the number there from the schematic. Anyways, this laptop had an issue over here. Okay. No, I just wanted to show you the model. It says Packard there. That's what I wanted to show you. Okay, so when I opened this laptop, it wasn't switching on. The owner said when they were plugging in the charger would flicker. Yeah, so the laptop wasn't working, but from what you can see, the laptop is on, the fan is spinning. I stopped the fan, so yeah, there it has kick-started again. And there is the blue light over there. The laptop is on and the CPU is actually warm. Anyways, from when I opened this laptop, the issue was it has a short. So I tried voltage injection and voltage injection didn't work because this is a 2 amp power supply. And the voltage goes up to only 15 volts. That's the maximum voltage, 14.9, 15, somewhere around there. Anyways, I did realize that the short was in the main power rail because I could, the moment I plugged in the charger, it was flickering. You know by default that the moment the charger flickers, you have a fault with your... Okay, that's cool. So let's put that. Anyways, you know the moment you plug in a charger and the charger is flickering, you have a short either in the with the MOSFETs, because that's the first inrush limiter and that's the second one over there. Then you have the current sense resist. Don't mind the way that I put them. Like I said, the equipment here is not as good. It's old equipment. I would have to upgrade to the same which I have in the shop. Anyways, so since the charger was flickering, my first thought was, boom, I have a dead inrush limiter. I have a dead MOSFET. But then I opened the thing and then I checked. I had a short over here in the main power rail. So I did voltage injection there. That's why I had removed that current sense resistor. But nothing was getting hot. Nothing at all, even at 2 amps. So what I then decided to do was that, no, it's cool. Let me see what I can do. So what I noticed is that for all the secondary power rails, because you know secondary power rails is this coil, that coil, any coil that you see, that is, you know, it's a coil and then you have MOSFETs around it. It's stepping down that 19 volts down to a specific voltage. For example, the RAM, it could be working at 1.2 volts, 1.3 volts. Yeah, then it has to be stepped down from 19 volts down to that 1.3 volts. So that's a secondary power rail. So from what I noticed is that with this model, secondary power rails, they first have from the main power rail you have got a coil. You've got a coil there. This is PL507. That's PL507. So one side of it is the main power rail, and then the other side is the one that's going into that secondary power rail. So you have 19 volts there, then it jumps, it's still 19 volts, then it can step down to that 1 volt, 1.3 volts for the memory. You have got that 19 volts, it goes past the coil, then it's still 19, then it can step down to 5 volts. Same scenario over here, you have 19, still 19 through the coil, get stepped down here, you get 3.3 volts. So from this point, what I realized is that I can actually remove these coils. If I remove this, because all the coils, they didn't have a short on them. That's the thing. If you have a short in the main power rail, it could be caused by a secondary power rail. So if you have a short in a secondary power rail, then you would expect one of the MOSFETs relating to the main power rail or the controller, something like that. So here the coils didn't have any short, so I decided to remove the coil. If I remove the coil, I'm isolating the main power rail from that secondary power rail. The short still remained. I removed this coil, the short still remained. I removed this coil and the short still remained. Then I had to jump to this one. This is a 1 volt power rail. I removed this coil and the short disappeared. Then I checked on the other side of the coil and the short was still there. So from that point, I looked at this thing. I came to the schematic diagram. Well, I didn't come to the schematic diagram exactly at that same point. I later downloaded the schematic diagram for another issue which I found later. But after removing the coil, and then I discovered that the short was gone from the main power rail and was now isolated to this region. It was now isolated to this region. So I simply removed these two capacitors because I could. You can clearly see that you have got a coil there, and those capacitors probably for decoupling. That's an output side, and there was no short on the output side, and the short was only over there, meaning that either the chip is dead or these capacitors were shorted. So from that point, I removed those two capacitors, and those are these ones over there, this one and this one. So the reason why I didn't check which one is dead was that it's pointless because they are next to each other. Most likely the other one is about to fail anyways. So I replaced them with capacitors that I took from this HP motherboard. And oh, my bike is okay, don't mind that. Anyways, I removed the capacitors from that HP motherboard, and then I put them right over there, and the short didn't come back. It was still good. So I tried to switch on the motherboard now, because now I had 5 volts and I had 3 volts, 3.3 volts. But I tried to switch on the motherboard and it did switch on. It would switch on for roughly 5 seconds and then off. So I'm quite sure you have met an HP which switches off after 5 seconds. Yeah, it can be caused by a lot of things, but in this case, the issue was still related to overheat. What I then did, at that moment, I didn't know where the issue was. So I started looking for the schematic, and the schematic, I found it on a website. It's Alicella. Anyways, this is page 33. I have to remember that. So let's go back to the first pages up to the top. Okay. So I came to the power rails section. So to the voltage rails. So you can see you've got V in, you've got battery, you've got battery plus. So it explains there what that is. V in, that's from the AC adapter. Battery plus, that's AC or from the battery, 12 volts, whatever. So yeah, RTC, and then there was the 1 volt power rail, and then there was the 1.8 power rail, and then there was the 3 and the 5. So the rest I didn't really mind because they are not S5 power rails. What I mean by S5 is that it's the voltage which you get when the laptop is, you just plug in the charger. You are supposed to get all of these voltages. S5 on. You are supposed to find these 8 voltages. Wherever you measure, you're supposed to find them. And then when it's in sleep, you're supposed to find these voltages. That's S3. And then SO, it's when it's running. For example, like this tail is running. It has also its SO state of power rails. So you're supposed to find all of them. Then yeah, you have to go down the whole list. So you see the S5 are a lot. Anyways, I came to the S5 power rails, and then I realized no, the 5 volt I already have, the 3.3 I already have. These 3 I didn't really mind them because they don't. I have V in, I have battery plus, this one B plus, which is the main power rail. So since I have this B plus, that means the laptop, I'm good up there. So I didn't mind the rest of them. This is battery plus. I don't mind that because I don't have a battery there. Anyways, I moved from those 3 and then I isolated those 2. So I was left with RTC 1 volt and 1.8 volt. So immediately I took the 1 volt always power rail. I pasted it in the stage bar there. Then I started looking for where it's created. So from there I said next. That was the first one, and then I said next. It brought me to this one, to the power sequence. not really coming there. So I said next, which took me still to the other side of the power sequence. That's still cool. And then I said next, this one is 1 volt always going into the EC. Yeah, the EC is most likely this. Yeah, I believe it's this. If not this, it has to be the CPU. I'm not sure who that is, like what chip this is, the USOC1H. Anyways, so I said next. That's not being generated there, so I said next, and then I came to this point. It looked a bit like it was being generated here, but then the description there says 1 volt always to 1 VS, so that's not it. I said next, then it took me here to that jumper there. So when it took me to this jumper, this is what I'm looking for. This is where it gets generated. So coming here, you can see it gets out through PL602. It's like PL602, then it brought me back again to this point. PL602 is this guy. So we're back to the same area again. So at that point, I thought maybe the chip is dead, because if the capacitors next to it were dead, the chip is probably dead. But then before I replaced that chip, I looked at the coil. I remember the principle that from the way the chip is, I first looked at the chip actually. The chip, first of all, it receives 19 volts V in, and then it receives an enable signal. So I did think that maybe the enable signal is not coming in. That was one of my things, and I was concerned that if it's the enable signal, then it extends the issue further. So I came again here. The output I already don't have, so I didn't mind about it. Then I looked at the whole thing, and then I saw like V in. Let me first check V in. So V in was not there. I only had 2 volts over there. And from that point, that's when I looked at the coil, because you know, from the main power rail, you have a coil first, and then it goes into the secondary power rail. So I looked at the coil which was there. It was giving me 2 volts. So I removed that coil, and the coil is over there. That's the third component over there. So after removing that coil, I replaced with another coil again from that HP motherboard, and I replaced it over there. And from that point, the laptop now does power on, because from that point I now had 1 volt. At first I didn't have the 1 volt power rail, so now we can fire up the multimeter. We'll put my ground probe on ground, and then my positive probe. So from the power rails, you remember we are supposed to have the 19 volt power rail. I'm checking it there on the coil, and I have 19 volts, 19.90 volts. So I checked again, I have my 3.3 volts, and then I checked again, I have my 5 volts, which was over there. So I had also my 5 volts there. Then I came and I checked for my 1 volt, and now I had 1 volt present, 1.08 volts. At first I didn't have it. So now when I press the power button, you can see the fan is spinning, and you can see the blue light is there, and now it stays on, because at that point it was only switching on the blue light for 5 seconds, but the fan was not spinning, meaning the system was not on. It was only showing that the EC is generating the 3.3 volts for the power, but it was not on. So give me a minute, I just want to change the song. I'm not a fan of this guy. I'm not a hater either, but no, I just don't like a guy. Okay, I would rather listen to this girl over there. Anyways, so from this point, we're just gonna take this motherboard and put it into that case which I showed you, and then we can see if we have a display. So yeah, I hope I do have a display. Just give me a minute to do this. Just give me a minute to get the case, which is right over here. We are just gonna plug in the display cable. I think it's the important thing. I don't know if I should put the hard drive. It's somewhere out over here. So yeah, here's the hard drive. I'm just gonna put it in as well, and hope that it doesn't need me to press any keys before it boots into the OS. So plug in the charger. You can also plug in the battery. I think that will make it cool, because yeah, that's the thing. It was after, when it was now switching on for 5 seconds, it was charging the battery. It was showing the orange light as well. So yeah, there we go. Power is on, and voila, we have a display, packet bell. And now we have a third LED there, that's for the hard drive, and we can see Windows is loading over there. I hope it will not pop up the information of the customer, so the personal details. Yeah. Anyways, the system is on, so let's see if it's gonna load the OS all the way through, although that's now not necessary because already it's on. So yeah. So my point was, the reason why I'm making this video is that if you can't get a component getting hot due to a short circuit, try to find a way to isolate that short. That's one way that you can solve the issue. My power supply is small, as I showed you guys, there it is. So I knew at that point that the power supply is the issue, because the one at work I have there, it can heat up anything because it goes all the way up. The amps are more than this. This is only 2 amps. So yeah, there is a photo for someone and their children. Anyways, yeah, the laptop is on and it is working, so I will have to assemble it and send it back to the owner. Yeah, from this point, guys, I'm hoping that you learned something, and as always, I don't know, as always what? I haven't recorded a video in a while, so I have forgotten my ending statement. Anyways, guys, thanks for watching. I hope you learned something. See you in another clip.